Group 16 Crank Adjustable Table. My name is Nora Zen, matrix number A168944, and I'm going to present introduction and teacher review. The problem statement is, as people and students nowadays spend a lot of their time in front of the laptop and computers, there is a need for a table with adjustable height that can accommodate the needs of many people. For the objectives, one is to provide a solution for the comfort of students that are studying for long hours in front of the laptops. Second is to choose the suitable mechanism for a height adjustable table, and finally to design a shaft that can be used for the mechanism of the table. For the teacher review, there are two main classifications of shaft. First is transmission shaft that functions to transmit power from one machine to another, example counter shafts and line shafts, and next is machine shaft that are an integral part of the machine itself, example crankshafts. For this project, we are going to design crankshafts. Next is the four type of adjustable height table. First is setup, they are fixed to user's requirement and only adjusted once during installation. Next, pneumatic that use a lever mechanism which is released and locked when adjusting height. Next is electrical, they are powered by electricity and only need to push buttons to adjust. It requires no physical effort. Finally is the crank type, they are the most popular type and cost effective. Crank allows user to easily raise and lower the height of the table. For this project, we are going to use the crank adjustable height table and design a shaft for it.
So next is the methodology. The methodology that we use in this project is shaft analysis. So in shaft analysis, we consider a shaft sizing by use stress analysis to locate the critical area, size of the design strength, and size of the shaft that meet requirement. We also determine the deflection and slope of the shaft as the function of the shaft. Next is shaft material. So several factors that we consider before select the shaft material such as stiffness, fracture toughness, and deflection of the shaft. Next, we also consider a material processing of the shaft. So to make sure our shaft is not fail, we consider the material process such as good strength, good wear resistance, good heat treatment process, and good machinability. Next, the methodology is a gear analysis. So in gear analysis, we consider a gear sizing. So to consider the size of the gear that compatible with the shaft by determining the diameter of the shaft by equation M equal to D over N. So next is a gear material. So the factor that we highlight before selecting the material of the gear are stiffness, fracture toughness, and good heat treatment.
Okay, my name is Muhammad Aziz and Muhammad Aziz. I will talk about the mechanism. Okay, this is our example system that we use for our table adjuster. Okay, our table consists of a shaft which has worms attached to it, and also a gear, and also the pinion which attached to the rod of the table. Okay, the user will rotate the hand crank, where the rotation will transfer through the shaft, and at end of the shaft has the worms, where the worms will transfer the rotation to the gear, and the rotation from the worms will determine whether to increase the table or decrease the tables. Has the gear will incline or decline from the pinion attached to it. So this is the example for the system. As you can see, it's increasing. So thank you.
This is of our shaft. First thing first, when we want to do analysis, we need to have our 2D drawings. So this is our 2D drawings. This is our top view, and then this is our front view. Then we proceed to the result. So when we have done with our 2D drawings, we come up with our stress analysis. Then by having a look, we can see that our safety factor is 15. The mean is 15 and the maximum is also 15. So this is our safety factor. Thank you.
Hi, my name is Aizat Alafudin Sukrifiamin. Firstly, the modulus of rigidity is calculated. We get G is equal to 46.3 megapascal. Next, the maximum shear stress is determined. We get 155 megapascal. The angular deflection is calculated using the formula TL over JG. Hence, we get 12.03 degree. The power transmit is 25.13 kilowatt. So the motor will transfer the maximum power through a connected shaft. Then the FOS value is 1.79, which means the product or the object is safe. For the discussion, our project is adjustable thus by using the shaft and the method is shaft alignment. Secondly, if the FOS more than 1, it indicates the product or the object is tough enough to withstand with the load. Thirdly, by using a shaft, it will lower the energy consumption. Then, shaft is non-elastic product that can protect the air and prevent climate change.